Okay, now we're going to talk about molar volume calculations. We generally use molar volume calculations when we do a titration. And a titration is a neutralization of an unknown acid or an unknown base. So the first thing that we have to do is know the formula. And the formula for molar volume calculations is the molarity of an acid times the volume of an acid equals the molarity of the base times the volume of the base. That will neutralize the solution. So the amount of concentration of an acid or base needed to neutralize an aqueous solution. Molarity, that's what the big M is. Be careful. Do not make it a lowercase m. Lowercase m stands for meters. So if you use a lowercase m, it makes your whole answer wrong because you're not answering in molarity. Okay, so the molarity equals the concentration of the hydrogen ions. And in a strong acid, that's the hydrogen ions, and in a strong base, it's the measure of the hydroxide ion concentration. So molarity equals the concentration of the hydrogen ions if you're talking about a strong acid, and it equals the concentration of the hydroxide ions in a strong base. Remember, that's what that little bracket thing right here is saying. That word concentration is this bracket. Okay, so remember we're saying the concentration, and then of course the H stands for hydrogen, and the plus lets us know it has a charge, which we call that an ion. So together, this bracket H plus says the hydrogen ion concentration. All right, because we see hydrogen ion, and then the bracket around it means concentration. This is the hydroxide ion, because of the negative sign, hydroxide ion concentration. The bracket means concentration. Okay, so we have to be able to read that shorthand to understand what we're saying. Remember, the volume of the acid times the molarity of the acid equals the volume of the base times the molarity of the base. Generally, you're going to be given 3 out of the 4, and you solve for the last one, whatever the missing piece might be, using Algebra 1, where you isolate the variable. So you say, what's keeping the thing that you're wanting to solve for alone? And then dividing by whatever that thing is that's connected to your variable. So you always start with whatever side you have both of the pieces for and divide by the one that was connected to the X. All right, so look to see what pieces you have. So I've got 0.5 liters, that's a volume because it says liters, of 0.45 molar, that's a concentration, that's a molarity, okay, of sodium hydroxide. So ask yourself, is sodium hydroxide an acid or a base? Remember, acids start with the word hydrogen, okay? So they're hydrogen something. And bases end with the word hydroxide. So there's something hydroxide. By the way, that's Arrhenius's definition. So sodium hydroxide means I have the base numbers here. So I know the two pieces that are my base numbers. I know the 0.45 is the molarity of my base, and the volume of my base is the 0.5 liters. And I am using it to titrate, that means to neutralize, bring it to a neutralization point, an aqueous solution of 0.2 liters of acetic acid. Okay, so that's my acid, and the liters means it's my volume. So what I'm trying to solve for here is the molarity of my acid. So if we go back and look to the piece where we plugged and chugged, here we are. So in your calculator, you put the side that you have everything. So I know both numbers on the base side. That goes in my calculator first. And then you divide it by the thing that's attached to your unknown, because that's what's keeping your unknown from being alone. So if you divide both sides here by 0.2, then this side cancels out, and this side is your equation. Okay. When you solve this problem, and don't just watch me solve it, take out your calculator. Make sure you are putting the right numbers in your calculator. So put in the side where you have both of the numbers, where there's no mystery, and divide it by the one that's attached to your variable. The variable is the thing you don't know, okay, your unknown variable. All right, so take those two, put them in your calculator, and divide by 0.2. You'll find that the molarity of your acid is 1.125 molar. The capital M is your unit on molarity. What will your capital M be on your volume? It depends what they give you the volume of the other guy in. So if you were solving for volume in this problem, if one of these two weren't known, you'd be solving it in liters. So the volume will be in liters or milliliters. It could be in any kind of liters, kiloliters. So you have to pay attention to the question. But molarity always comes out in uppercase M. All right. So once again, read your problem, see whether they have given you the acid or the base as your things that you know. Set up your problem. MV equals MV. All right, so I've got 20 milliliters. That's a volume of 0.45 molarity. Of course, that's a molarity, 0.45 molar. NaOH. NaOH is a base. So I've got, again, my two base numbers. It is used to titrate an aqueous solution of 10 milliliters of HCl. That's a volume. Both these numbers have to be in the same units, so they are. What is the hydrogen ion concentration of the acid? So when we titrate, we do pretend that all acids are strong. So when we come out with the name of the molarity of our acid, it will equal the hydrogen ion concentration, okay, because molarity equals the hydrogen ion concentration. Okay, so let's plug and chug here. So I know the side where I know both of the numbers for the base. You put those in your calculator first. Always start with the side that you have both of the numbers and divide by the one that's keeping your X from being alone. So when I reestablish my problem as 0.45 times 20 divided by 10, my molarity is 0.9. So the hydrogen ion is 0.9. It doesn't tell me in this question, of HCl, sorry. I was going to say that it was HCl, but it really doesn't matter because we titrate all things as strong. So if you're using a titration, you don't have to worry about that, whether it's a strong or a weak business that we did when we were given a solution by name. But this one would have been strong anyways because HCl is a strong acid, so either way we wouldn't be confused. So 0.9 is the hydrogen ion concentration because in a titration all is strong, but even if it wasn't, HCl is a strong acid. Molarity equals hydrogen ion concentration. All right, set up this problem. Oh, this one is the same problem, but now they're asking me to solve for pH. All right, so you've got to put something else together here. So MV equals MV. If I know that if I jump into the square at 0.9, 8.9 is my molarity. So 0.9 is my hydrogen ion concentration. Remember, I am jumping into the pool, this is an acid, on the side for hydrogen ions. All right, so then I have to go down. So that means I'm going to take the negative log, right? The negative log of my 0.9. So the pH is the negative log of 0.9. And that means my pH is 0.045. That's the pH of my substance. pH is the negative log of 0.9. All acids in a titration are treated as strong. I've got 14 milliliters of 0.6 molar HCl. It's used to titrate an aqueous solution of 20 milliliters of NaOH. What's the OH minus concentration? What's the hydroxide ion concentration of the base? So you've got both numbers for your acid this time. Set up your problem, pause the video, and come back to see the solution. Okay, hopefully when you set up your problem, you saw that you had both sides of the piece that was acidic. You have the volume and the molarity of your acid, and you have the volume of your base. So what's keeping your molarity of your base from being alone? The 20. So both sides get divided by 20. That cancels out the 20 on this side, and you end up with the molarity of your base being 0.42. So now that is the hydroxide ion concentration of your base. That's the hydroxide ion concentration of your base. What's the pH of that same solution? So if I jump into the square on that side of the equation, I'm going to jump in over here on the hydroxide ion side. And I want to go down to POH, and I want to go across to pH. So it's going to be OH is where I jumped in with 0.42. I take the negative log of 0.42 and I end up with a POH of 0.4. Then I take 14 minus, and I just keep it writing in my calculator. This number doesn't say 0.4 in my calculator. That's not my end result. So don't write 0.4 down and then do this piece, even though you do get the same answer in this particular incidence. You don't round until you get all the way to the end of your road. So just keep this writing in your calculator. I took the negative log of 0.42. Or I could have even just taken the negative log of my answer if 0.42 was the last thing in my calculator. Then I take 14 minus my answer, and I get to 13.6. Now that's not the only way in this square to get to the pH. I could have gone this other direction, across here. So I could have done 1 times 10 to the negative 14 divided by 0.42. When I got to my H plus, that would have been 2.4 E negative 14. And then I could have taken the negative log of my answer. And by the way, that still brings me right back to 13.6. So if they ask you for one of the components that are a part of your square calculations, and they give you the information to get to your molarity, if they give it to you and you are trying to find out something to do with the acid in your molarity problem, you will jump into this side of the square. And if you're trying to figure out something in your solution like this one was about your base, then you jump into this side of the pool. So it depends on which side you jump in, depends on whether you solved for the hydrogen ion concentration or whether you solved for the hydroxide ion concentration. All right, go do your practice problems about molarity.